Hey folks, good night everybody. We are about to start. I'm just giving a couple of more minutes for people to join, but I kick off this session very soon. Just stay with me. We're keeping an eye on the chat too, on the YouTube chat. So if you have questions or you wanna add something to it, just let us know. Actually, I'm gonna say this is me, right? The one chatting here. Hello, that's me. I will keep an eye on the chat. I have just posted something there. Just if you guys have questions or anything, just post them there. I'm muted.
Yeah.
Thank you very much. Yep, thanks. So I don't know what you guys heard. I said that I was gonna keep an eye on the chat. Yeah, I should have an alert. So I was gonna keep an eye on the chat in case you guys wanna say something. Can you guys hear me? It says that you lost audio, Brian. Maybe it's just not being updated. Okay, awesome. So yeah, there's a little bit of delay here. We're about to get started. But the idea is, and hello everybody, Jane, Brian, Abdul, everybody. How long it's gonna take? It's usually 40 to 45 minutes. We try to wrap it up soon enough so you guys have some time to do the practice. These workshops, activities, they all have some sort of practice. So we try to do exactly that. Let's actually get started. I'm gonna post something here so everybody can see it. But basically, what we're gonna do today is a quick overview of what you can do with Python for data analysis. What are those capabilities? What are the tools you can use, and what's the extent, right, at which you can use them? It's gonna be pretty interesting because you will find that with just a couple of tools, with just a couple of commands, you will be able to, I don't know, get a lot of data, process it, group it, reshape it, create visualizations, beautiful visualizations like, I don't know, line charts. We're actually going to use a couple of different libraries like Matplotlib and Seaborn, and of course, Boki, which is this dynamic one that it's very good. So yeah, again, just 40 minutes, you guys are gonna see what are the capabilities of all these tools with Python and how you can replace, for example, Excel, Tableau with your own tools. All right, that's the objective of the workshop. So usually we also try to answer the question, who is watching us, right? So if you're usually working with these tools, like for example, Excel is the one that I can think of, this is going to be a good opportunity for you to see how you can replace some naive tools like Excel with something a lot more powerful. Excel is very good, right? We all know that it's a very, I don't know, developed tool, but nothing beats the opportunity of working with your own programming language, right? Excel is a tool that is already built for you, and it has boundaries and it has limits. And I'm speaking about Excel. I could say Tableau. I could say pretty much any other one. The difference is that when you have your own programming language, there are no limits. You know, you have these tasks in which you have to combine data from multiple data sets. You have to extract it, you have to parse it, you have to scrape the web. You can just do it all with one tool. You know, that's the real beauty of it. So I'm gonna share my screen in a second, and we're gonna get started. I'm gonna keep also the chat here. There you go. We are live, I would say. So of course, we are doing this as part of our more detailed data science program, which includes what you guys are going to see today, plus even more. We're going to learn a lot more about programming, databases, API management, and queries, and scripting, and a lot more. So this is just a quick pick at what you guys are capable of. If you are interested in learning more about it, especially if you don't, so if you like what you see, it's like you say, I really like what I could be doing with all these tools, but of course, it gets hard to sometimes follow some of the steps that we do. Our course can be a good start. Or it's just Python and programming, so there are multiple mediums. I want to introduce what we do. It's just our course is a couple of live. It has two live classes per week. That is, for example, starting in March, Tuesdays and Thursdays. So there are 2 live classes with a real teacher explaining topics, and then also includes, of course, career services and a final project and a lot of that. So if you guys are interested, just go ahead and check it out. rmotr.com. You can use DSC. That's gonna be a short link for that. All right. So today we're going to be using this curriculum, which is on notebooks.ai, remote curriculum, intro to data analysis with Pandas. I posted this thing in the video description. I'm going to post it again here, just in case you guys want to use it. And this is a very cool service, notebooks.ai, in which we are participating, adding a ton of content. And basically what it does is you can fork automatically, can create Jupyter Lab environments. Jupyter Lab is this evolution of Jupyter Notebooks, and you can create these environments and basically work on your data analysis from the cloud. All right, there is no need of installing libraries. There is no need of installing I don't know, tools, etc. Everything is installed, including Python, including, for example, all the data analysis Python libraries like Pandas, NumPy, Matplotlib, Seaborn. It's all of that is already included. Deep learning libraries like Keras, TensorFlow, they are also included. And of course, this is just an environment for you, so you can install your own libraries if you want them. So to get started, I'm going to open the first notebook right there, which is workshop, right? The second one, of course, has the exercises you folks will have to do. And just a quick pick at this one. It has a very nice functionality for you guys to see solutions, etc. And we're going to get started with the one on workshop. You can follow the process. You can follow what I do just from within this same view. So again, you go to this view, you can just click on fork this project. It's going to create this copy for you. So within it, we're going to import a couple of libraries. I'm going to just go directly to the issue of data analysis here. There's not going to be a ton of introductions, boring theoretical interactions, because to be honest, if you've been working with data analysis, you will probably know what we are trying to achieve. What I'm trying to show you is how we achieve it. All right. So The first thing I'm going to do is I'm going to import a bunch of these libraries that are all part of the Python ecosystem. Again, they're already installed in the service. If in notebooks.ai, if it isn't, you can always install it on your own. So I'm installing these libraries, and the next thing I'm going to do is start using Pandas. Pandas is probably the most, along with NumPy, the two most important libraries, these two, Pandas and NumPy libraries in the Python data science environment. NumPy is probably the most important in theoretical terms because it's the one that got everything started. It's for scientific and for numerical computing in Python, makes things very fast, very good performance compared to, for example, something like C or Fortran. And this library, NumPy, started a long time ago, and basically they were a bunch of, it was a group of people trying to get a lot of, like, they wanted trying to do data analysis or just, again, numeric computing with Python, but they didn't like the performance of Python. So what they did was they combined all the low-level abstractions, for example, C, assembly, Fortran, with something like Python. So it's very neat to write, but internally it runs very fast. So that's a good thing about this NumPy library is one of the most important ones. On top of it, we have Pandas, which is a library that it's built for data analysis and for manipulating data in general, cleaning it, identify outliers, reshaping it. It has built-in capabilities for visualizations along with Matplotlib. It's a very, very interesting library, Pandas. We're going to use them. We use it all the time. And we also have these two that are for visualization, right? Matplotlib is the core visualization library. It's pretty much the grandfather of all the visualization libraries. And on top of it, we have Seaborn, which is built on top of Matplotlib. So it's literally on top. And what it's going to do is it's going to let us create simple statistical-based visualizations in a really simple way. Matplotlib, what it has is that it's not so simple and so friendly, right, to get started with. Seaborn, on the other hand, it's a lot better. So what we're gonna do tonight is start working with Pokemon data. You guys can open the spreadsheet that pretty much has the whole data set of original Pokemons, all right? So this is, this looks like an Excel table, right, in a spreadsheet. You guys know about it. This is an spreadsheet. You're probably familiar with it. What we're gonna do now is we're gonna see how we can pretty much apply the same transformations in the same processing with Pandas. So the first thing I'm gonna do is I'm gonna read a CSV file into Pandas. To do that, what I do is the read CSV function. And this is what I get. It's what Pandas calls a data frame, all right? This is the Python/Pandas equivalent of a spreadsheet, all right? As simple as that. This is a spreadsheet. Pandas has this concept of a data frame, which is this tabular, two-dimensional data that pretty much holds the same, right, the same capabilities of a regular spreadsheet. So this is what we use all the time with Python and data analysis. These Pandas data frames are just like bread and butter for data analysis. So these data frames, and this is just where we have just dive into it, guys. There's no introductions. We're doing Python data analysis right away. These tables, right? I need to first introduce the table, the data structure, and we're gonna do the analysis later. But this table, basically here, what it has is an index, okay? And this index is what we're gonna be using later to access our data directly. In this case, this Pokemon dataset has a number already built in, all right? Because the Pokemons, they all have a number associated. Sometimes your data does not have an index. Pandas is still creating one for you, one incremental here, starting from 0. And actually, if I show it to you, it's gonna say range index. Let me show it to you. It's the default one that it's creating. Nevertheless, again, we do have something to index our data. So for example, if you're working with a, I don't know, time series, you can use it, the time or the date of that, I don't know, the stock price, as we're gonna see in a couple of minutes. That is all possible. In this case, you have to choose what is gonna be that index that is gonna let you identify your data. In this case, it's going to be, again, the number. I'm going to assign a name to it just because we can. A Pandas data frame can have, a Pandas data frame's index can have a name. And this is now my index, which again is composed of all the numbers of the Pokemons. That is it. As I told you, Pandas is built on top of NumPy. All right, so this is a very important definition. NumPy is this very fast scientific or numeric computing library. And internally, what you guys will see is that this whole data frame is just like a nice wrapper on top of the very efficient NumPy data. So this is what it's stored inside the data frame. This data frame is pretty large. Let me actually show you the whole thing pretty large. I mean, it's just 700 rows. It's not even large, it's just small compared to any regular managing of data that you guys have to do. But just for the sake of displaying it, you will see that it's pretty large. It's like the libraries, the Pandas library is kind of just like stripping part of it. So it shows the whole thing, like the head and the tail. We usually use this method of .head. That's going to give you the first 5 rows, right? So we use both head and also tail to show these things. All right, so I told you this data frame is this 2-dimensional, right, tabular data. And it has a couple of properties we can see. The first and obvious one is the size, which is just the entire data points that you have. So it's the number of rows combined by the number of, multiplied by the number of columns. That is given by the shape of a data frame. In this case, we have 721 rows and 12 columns, right? That should be the final result of size. How many dimensions we have? We have 2 dimensions. It's a 2-dimensional data structure, vertically and horizontally. Just spoiler here, we're not gonna do this a lot in today's workshop. Pandas can also, data frames can be multi-dimensional. You can have more dimensions. If your data has 3, 4 n dimensions, you can still work with that with Pandas. And finally, as this thing is 2-dimensional, you can always like reshape it, move it. And just in this case, what we're doing is it's like, just reshaping our data to make it a transpose, right? So each column becomes a row and each row becomes a column. So as I told you, the underlying data of a data frame is called internally. It's contained by NumPy arrays, which is the main data structure of NumPy. We can actually get a handle of that to make our processing more efficient. So we can have a little bit more details on how to work with it. So these are the columns of our data frame. Let me do head here again. Sorry, my bad. Head, there you go. And what we have right here are all the columns that are available in our data frame. Each one of these vertical columns, right? Each one of these columns, which are like these vertical arrays, can have an independent type, right? So this is clearly an integer. This is clearly a string. But what about these type? What is it, right? What about type 1 and type 2? Are they just plain old strings? Well, actually, NumPy and Pandas, they both have like these specific types you can assign to columns to make your processing a lot more efficient. One of them, which is very important, is the categorical type, right? So in this case, we can assign type 1 to a category type, right? If we check the different data types of our data frame, we can do it both with a low-level overview of it, which basically uses NumPy. And in this case, you see that these 2 that I have just transformed are categorical. Everything else now is an integer 64. And the final one, legendary, is a Boolean, either true or false. This is gonna speed up development a lot internally because NumPy and Pandas are using like smart tricks internally to save memory for these special types. Each special type that you assign, I mean, why do we want to assign types, or why do we want to complicate ourselves assigning special types? Aside from the memory efficient, each one of these types will also have sometimes special capabilities, right? So there are just particular to that type. In this case, we do the df type 1. What we have is this categorical column, and it has a summary of all the different categories and the count of values for each one of them. So it seems like we have 105 water Pokemons, 93 normal Pokemons, 66 grass Pokemon, etc., etc., etc. So putting all together, you can do this process by just reading the whole CSV in just one line, right? This is called one line, even though it looks like multiple lines. But in just one expression, you can say that you want to read this Pokemon data set, you want to set number as the index, and you want to set these two special types for these columns. So I'm going to do it all at once, and this is what we have. As you guys will see, everything is still in place. So let's start accessing individual columns. Once you have pulled your data, that isn't anything more complicated than this read CSV. And this is a procedure we usually recommend. It's just go ahead and read the CSV alone. Just, read a CSV without any tuning and start modifying and start learning from it. And once you're done with it, you can then kind of condense everything in just one line for future processes. But at the beginning, it's better to just start with the plain old read CSV. So once you have read your data, you'll start modifying it and selecting it, right? So I have here my spreadsheet. What if you want to just select one column of these table, right? So for example, right here, we have attack. We want to select the attack column. So right here, what I'm going to do is select attack. In this case, what we can do is just use the data frame indexing capabilities or selection, right? That it's going to let us select by independent columns. So in this case, we can select a subset of the data frame, which is just the attack column. All right, so data frame at attack gets you that column. We usually use the dot head. So again, we have the first 5 elements, and we have like a really long list of numbers, but of course, you can avoid it. What happens if you want to select multiple columns? So here we want to select both attack and defense, these two ones. So we're going to do attack and defense for as strengths. What happens if you want to select individual items like 3? I want to select everything under 3. I want to see what it is, right? Or everything under 6, etc. So what you can do there is just select by the index with the lock attribute, df or data frame dot lock, and here you can pass the index value. In this case, the index is a number. If you have something different, of course, you have to pass that index. This index selection is very powerful. You can pass multiple things. One of them is, for example, you can pass a range selection. You can select starting from index 3 up to index 10, including 10. This is something that differs from regular Python. I'm going to select all these elements right here. You can combine index selection with also column selection, right? By passing first an index. I want to select this index, and then passing a list of columns that you want to select. So it's not just I want to select these particular item, for example, right here, Venusaur. It's also that you want to select from Venusaur, not every value. I want to select only attack and defense. So here we can also select multiple, like just hand-picked items. I want to select the items 2 and 3, and I want to select these columns. You guys can take this to infinity. As many rows you need and as many columns you need is very, again, flexible for your selection. Something else you can do is select by sequential position. So in this case, the index has a numeric item. Maybe that doesn't happen. And you say, I want to select the first element, right? So in Python, things are indexed by zeros or 0 indexed. The first thing is 0. The last thing is -1. So you can use, again, sequential selection instead of just index-based selection, sorry. Once you guys have a data frame, you have summary statistics that are accessible in the easiest way possible. First of all, we have this describe method, and what it's going to do is it will give you like the most important summary statistic for each one of numeric columns. All right, so the numeric column is going to give you summary statistics. For example, count how many elements we have. What's the mean for each one of those values? For example, the mean of attack, the average attack is 75. What's the standard deviation of attack? What's the minimum or the maximum of attack? All right, and different percentiles or quantiles. You can also apply these individual summary statistic methods to each one of your columns. So I want to get the mean or the sum or the maximum or minimum of each one of these total column. All right, so for total, we are getting each one of those. Everything good so far. I'm taking a look at the chat from time to time, so you guys can pose your questions if you have them. What else? We're going to do a little bit of visualization to get things going. We're going to use Seaborn, which again, I told you, it's this very simple to use library for visualization. It works on top of Matplotlib. And basically what we're going to do is a dist plot. It's a distribution plot, so we can see how that given column, right, the values of that given column are distributed within our data. So in this case, you see like where is clearly the mean of the data. In actually, we can use here attack. The mean is 75. So the mean is around here probably. And then you have, of course, the regular distribution of the data. Defense speed, all different distributions you guys can check. So what we want to show you here isn't anything fancy. It's just how simple you can get visualizations going with Python. So this is something we do all the time. What about correlation? How is total correlated to attack? Is attack better for a total or has more influence on the total? Or what about defense and attack, etc.? You can do a correlation heat map. And in this case, what we're getting is, again, the correlation measure for each one of them. So for example, we see that HP has a lot of influence in the final total. We're going to see that there is a formula for this, actually. But also, for example, I don't know, there is high correlation between, well, not that high, but let me check if we have something better, like attack and HP, or there is pretty much attack and defense. So just, again, not even perfect, but you can see where there is a little bit more correlation with the others. Similarly, we can create a scatter plot. So this was a distribution plot showing you the distribution of your data. This is a correlation plot, something you can do with just one line of Seaborn. And also with one line, you can also do a a scatter plot, which is basically a linear regression model, because it's this literally fitting a linear regression right here. But again, it's just a regular scatter plot displaying two variables and letting you compare these two variables, attack and defense. So each one of these points is a Pokemon, and you can see what's their attack and their difference, and you can see if there is any linear relationship between these two variables. What about attack and total? It's pretty much the same thing, as you folks can see. So there is this major topic that we have to talk about. It's a little bit technical. It's a little bit not so friendly at the beginning, but I want you guys to bear with me, because I am sure that you will pick it up as we are going through it. The first thing we're going to do is we're going to reduce this entire data set, and we're going to just work with the first 10 elements. All right, that's just because of simplicity. We want to make sure we can follow the example, seeing the real data. So again, assume that we have just these 10 Pokemons, nothing else, and we're going to start working with this. I show you the regular selection, in which you could do something like df.small, for example, .lock, sorry, and we can get, for example, the Pokemon at index 5. Or you can actually use something like, I want to get the Pokemon at index 5 and also on index 7. You can get two different Pokemons just by, again, cherry picking their indices. There is a third type of selection in which you are passing a list of booleans indicating which Pokemons you want to get. So in this case, we have, for example, 0, 1, or 1, 2, 3, 4, 5. I want to keep this one. Actually, I should invert this whole thing. False. Quick hack. Improvised. There you go. So 1, 2, 3, 4, 5. I want to keep this Pokemon, so I'm going to pass it through here. 6, 7. I want to keep these other Pokemon. All right. So I am again cherry picking these 2 Pokemons that I want to get, 2, 3, and Pokemons that I want to pick, by just specifying a true in their position. Everything else is false. So basically, you have to pass an entire list of true and false values. False indicates that you don't want to keep that, and true indicates that you do want to keep one, or you want to retrieve one of these samples. Here's another example for you guys to check. So how is this even related to some useful selection, you might ask? Because I mean, it's so annoying to be typing all these things manual. Well, it turns out that NumPy initially, and Pandas picked it, developed a very smart way of doing selection. So for example, if you ask, from these Pokemons, what are the ones that have attack greater than 80, right? When you do this sort of comparison, this Boolean comparison between a column, an entire column, and a number, a scalar, what you're going to get is a Boolean array bug. So in this case, it's going to tell you that 1 and 2 don't have attack greater than 80. The third one, the 6th one, and the 9th one, they have attack greater than 80. So that means you can combine these Boolean array. You can combine these Boolean array with your selection, right? So you can say, basically, I want to select, and this is my Boolean array, but you're not explicitly defining it point by point as we're doing right here. What you're doing is just passing the result of your query or selection process, filtering, that you know returns a Boolean array. So by combining these 2 ends, we can arrive to this final result. All right. Here we're listing, we're just selecting. It's like a query, it's like a filter. We're filtering only those Pokemons that have attack greater than 80, 82, 84, and 83. You can combine this selection with the regular column selection as we saw it before, and this selection can take any form as long as it makes sense, right? So for example, all those Pokemons which type 1 is equal to grass. If we do that, we get B selection. Type 1 grass, type 2, type 1 grass, and type 1 grass for each one of them. We can actually create or apply multiple Boolean operators to these Boolean selections, right? So this is a Boolean selection. If you guys are having issues understanding this, this is more of a regular programming thing. We actually covered this in our course in like our 2nd week. It's very simple to understand it. Don't worry. But once you understand about these Boolean operators, you will see that there are multiple characteristics or traits or even categories of Boolean operators, right? There are, in this case, is a greater than operator. You also have, of course, lower than, lower than, equals, different from, or not equals. And also you have another ones that serve as concatenation. You can do the AND operator. I want to get all the Pokemons which they have greater than 80 in their attack is greater than 80, and also another condition, both have to be met, and their speed is greater than 80. So again, as a summary, we're gonna get all the Pokemons which attack is greater than 80 and speed is greater than 80. I need both of these conditions to be applied. That the result of all these operations is, as usual, a Boolean array. So we can combine that with our selection. So in this case, you're getting that unique Pokemon which has attack greater than 80 and also speed greater than 80. So this is Charizard Pokemon. There is another concatenator, which is OR. I want to get all the Pokemons that have attack greater than 80 or speed greater than 80. And of course, we can get a different result here, true. And of course, Charizard is also in that list. So in this case, you have, for example, Venusaur has attack 83, but it's not that fast. In this case, it's greater than, it's not greater than equals than. And in this case, Blastoise attack is 83, but the speed is only 78, right? So again, in this case, the idea is that we are doing an OR operator. You can combine these operations with your Boolean selection, right? That's the idea of what we're doing right here. This is another type. You can select all the Pokemons, which type is either grass or water. This is basically an OR operation disguised. A couple more tools for you guys to check if you want later, but basically what we're gonna do now is we can check, for example, all those Pokemons that are legendary. All right, so these are I forgot the name, sorry. All the legendary Pokemons, and as legendary is already, let me show you again the info, the type. Legendary by itself was a Boolean. So we can apply that Boolean here. It's going to let us get all the legendary Pokemon, all the ones that have this column equals to true. So I can use that to create more visualizations. Right here, you have a pie plot, right? With pretty much a count for each one of them. We can also ask for all the Pokemons that are part of generation 1, right? So this is the entire list, and for all the Pokemons that there contain SOR on their name. So we do str contains, and within str you have a bunch of methods. We actually have many interesting ones to apply there. In summary, what we can build, and I'm going to spend a couple of minutes here, not a couple of minutes, but I want to give you a little bit more detail, is these two nice charts, which are showing you type 1 and type 2 Pokemons as a count, how many Pokemons are type 1, bug, dark, dragon, electric, etc., and how many type 2 are bug, dark, dragon, etc. So you can see, for example, that flying type 1 Pokemons there are not a lot of them, but we do have a lot of type 2 flying Pokemon. So it's like, it was this regular Pokemon. Let me see if we can find one type 1. So we're going to do vf.lock all those Pokemons which type 1 is fire, right? And let's get that. And also we want to get all those Pokemons, actually get this thing, which type 2 is flying, did I told you? Fire, no, fire or flying, sorry, flying. There you go. So here you have Charizard is type 1 fire and type 2 flying. All right, so it's very common for Pokemons to get these characteristics on type 2. Right, that's what we can see with these simple count plots. In summary, what we're doing is we're using a count plot from Seaborn that basically lets you out these bars, right, per a given category in your data. I could extrude this whole thing, but I could also add hue equals generation. Maybe this doesn't work. I don't want to spend a lot of time with it. Yeah, there you go. The subplots. There you go. So I can discriminate it also by generation. That's just a little bit more analysis for you folks to see. So Patricia. Oh, we can check into that. maybe an error with the workshop notebook. We're gonna check in a sec. So what we're gonna do now is a little bit of data cleaning. All right, so it's a very common operation once you guys get the data somehow to start, of course, the process of cleaning it. This data set, the one we downloaded it, is pretty much clean already. So what we're gonna do is first get it dirty. All right, first we're gonna add a couple new Pokemons by hand, and what we're gonna do is add a couple of interesting things. First, we're gonna add a couple of outliers, which their total is really high. All right, so these totals gonna be very, very high. We're also gonna add a couple that are, for example, that have generation in nans. So these are empty values, or also that their name is not a number, which is basically invalid. All right, so this is the new data that we have just generated. Again, we're just untidy things on purpose so we can clean it in a second. The first thing we're going to do is show you how you can create a new column for your data frame. And this is a vectorized operation. What we're doing is we're, for example, summing all the columns in a data frame. So you will see that the total column we had is basically the sum of all these other columns. Right? So it's total calculated is this new column we have created, which is equals to summing HP, attack, defense, special attack, special defense, and speed. Right? So summing all those columns gives you total calculated. That, as you can see, is pretty much the same thing as total. This is the distribution of total. There are multiple ways of doing visualizations with Pandas. What we have seen so far is the seaborn one. This is what I have shown you before. We actually have also a quick way of doing it, which is .plot.hist. It's going to give you a histogram of your data. This is pretty much the same thing. The only difference is probably the number of pins, but it's something you guys can change. As you will see, both here and here, this data seems to have a couple of values that are very high. It seems like our data is always concentrated on this portion of the values, like with a mean of 400 maybe, and then you have a couple of values which have like above 900. This is a clear outlier. It's something we're going to be cleaning in a second. There's just another way for you folks to calculate different values, just showing you for if you want to fill it later. So we were talking about these very high total Pokemons. These are what we call an outlier. It's a value, right? That it's an outlier. It's just its value is too high or too low, and it's not representative of the distribution of the whole data. Outliers happen just naturally, or they are sometimes also generated by incorrect, erroneous data. It's important for you to know how to judge that. It's important to know if the data was badly generated, if it was just a bug, or it's something that is happening accordingly, right? So usually, in sports league, you have every sport representative is average, most of them, and then you have a couple of like LeBron James or Lionel Messi, these amazing people that just get every value off the chart. These are outliers. Again, sometimes happen naturally, sometimes they are just incorrect, erroneous data. Your job is to understand which one is the case. In this case, how can we identify outliers first, right? The first step is figuring out how to identify it or identify them, so we can then decide how we are going to clean them. Is this bug in the data? We're going to go fix the bug that's generating the data. We will probably delete these ones. Are they just naturally occurring? We will probably leave them as they are. To do that, we're going to use a box plot. This is probably the most common type of plot for the outlier detection. Is right here what you guys see. Basically, these values right here, these three values are the outliers. That in this case we cheated. they are the ones we added manually. This is a box plot in which we are pretty much discriminating by the generation, right? So we see that generation 1 is the one containing all the outliers. So this seems pretty suspicious. Usually, naturally occurring outliers can happen in multiple categories, independent of what category you have, right? In other case, they might be erroneous. So the question is, what is this thing? Right? What this box represents, these whiskers represent, with these points represent. These points are, of course, the outliers, but what is everything else? So there is a little bit of an important statistical analysis here you guys have to make. But basically, what you guys have is that outliers are, box plots are represented in this way in statistical terms, all right? Something we cover in our course, it takes some time, but basically the box represents Q1 and Q3 in terms of quantiles, all right? Or the 25th and 75th percentiles. The line is the median of the population right there, all right? And then you have a couple of whiskers that are computed with this formula. Q3, usually you can change it, of course. Q3 is the third quantile plus 1.5 of this interquartile range, which is basically Q3 minus Q1. So I'm going to do this whole thing, and we are basically, here's called fence low and fence high, these two lines. You can call them whiskers, whatever. But basically, we have defined these values are providing the limit for our data, the lower limit and the upper limit. So now we're going to find, or we're going to select all those Pokemons which trespass, right, which are either above or below these fences we have defined, above the high fence in this case, or this one right here. These values are the ones, of course, we manually added 905, 974, and 950. Again, we manually added those, so we know it already. How can we clean them? Just a selection. We're gonna select everything else and we're gonna leave them as they are. There is also a drop operation we can do. We can show you that later. But for now, this gets the job done. As you guys can see, there are no more outliers in our distribution. So now the question is, when I added these values, actually right here, df.tail, we added a couple of values that were empty, right? So for example, these Pokemon here, we don't know what's its name, type 1 or type 2. We just have a little bit of information about their totals and numbers. This is useless. I mean, what we can do with these Pokemon? So we're going to have a strategy for that. What about Pokemon with generation in none? What about, I don't know, just making things up? There are multiple things that can happen with your missing data. And of course, there are multiple strategies for you to overcome that issue. The missing data is represented by this not a number value. And you can basically get a summary with this method. You get all the ISA numbers and you get a sum of that. And it gives you all those values per column. So it seems like there's only one Pokemon that has not a number in type 1, this one right here. This one right here. And type 2 seems to be a very common column to have not a numbers. This is fine. And then we have generation. We have 2 Pokemons that have not a numbers there. These 2 that we have said before. So again, we need a strategy to overcome those limitations. The first thing we can do is let's drop all the Pokemons which have not a numbers in their name, right? We know we can't handle these. We need the name to work with it. So to do that, I'm gonna just do a drop NA operation, saying that our only important subset to delete data is the name. So any Pokemon that has an NA on their name will be dropped. The f.tail again is going to show that last Pokemon empty is no longer here, right? This one, 1099, is no longer here. What about generation? What are we going to do with generation with those Pokemons that have nuns here? Well, to be honest, if they are at the end of the data set, they are probably part of the final generation because the data set seems to be sorted by generation. So in this case, what we're going to do is just a fill NA method, right? And for that, we're going to do a fill NA method with the this is confusing. The fill NA function, let me call it, with the method forward fill. All right. So what we're going to do here is fill the values and kind of cascade them or overflow them. So in this case, 6 is going to be dropped here and here. So I'm going to do that. I'm going to do another tail. And as you can see, these Pokemons now have generation 6. Something else you could do is add, for example, to, I don't know, just making it up, but to generation, you can add something completely arbitrary. You could say, for generation, add it with fill NA equals 1. So you can put 1 and 1 here if you know the volumes. Dropping data is very simple. So I'm just showing you the drop method. And again, you can always kind of picture these operations in comparison to what you would be doing with Excel, right? So it's like, what would you be doing with, or a spreadsheet? What could you be doing in here? Sorting values is very simple too. So sorting by defense, ascending, so weakers above, or sorting by defense, again, descending, defense, my man. Descending, right? It's actually ascending false, is pretty much the other way of sorting. Makes sense so far? We're pretty much done with this activity, at least. All right, so finally, I want to show you really quickly how to do grouping and aggregation with Pandas. If this is the first time you're saying this, let me tell you something. I'm sorry about it up front, but I'm going to tell you that you will probably not get at all what we're, not at all, most of what we're doing. You will understand, of course, the concept, that's the idea, but the way we're doing it might sound a little bit tricky. And this is fine because it does take time. It does take time to understand it. We actually cover it first. For example, in our course, we try to do first database aggregations because it's like a really common way of thinking about data. And then we move into the data, into the Pandas way. So the first thing we're going to do is group by generation. So grouping works by giving a set of data. Right? These are all part of generation 1, right? It's going to split these data in all the different values you have for generation. So in our case, we're going to have a couple for generation 1, another group for generation 2, another group for generation 3, etc. And then you can run a given aggregation on top of it. So with this new group that you have generated of generation 1, you can get a given aggregation operation. For example, the average of attack for each one of them. And this is what we get. Generation 5, the attack was 80, 480, 675, 73, 72, and 68. These two are actually soft. So seems, right, like there is a little bit of a small trend to go up with the attack. So we can pretty much visualize this with, oh, these are not ordered, 5, 4, 6. We should order this. So I'm gonna do the sort index. There you go. There you go. So this is what we get right here. So this is how the average attack of Pokemon has changed across multiple generations. Very interesting stuff. and so simple to generate. As you guys see, it's just a couple. First, group by generation, then get whatever you want to get and do the given aggregation. Do you want to change the aggregation? Do you guys want to do the minimum? Let's get the minimum attack for each one of the generations. Simple, right? So the minimum one for each one of them. Let me show you the actual value. Of course, this variable is no longer valid. But again, 5, 10, 15, 5, 22, 22, 25, 22. So again, you are grouping, you're creating individual groups, and now you're running a given aggregation on top of it. Let's get the total sum, all right? So let's get the total sum of values, right? And of course, this is depending on how many Pokemons you have for each one of the generations. Make sense so far? I want to see if you have any questions. Patricia? Good to know you're having a it's working. Kitty, I don't know what a shiny is. Sorry. Can you get a little bit more details? It's probably a Pokemon term, isn't it? I don't know what it is. Patricia, don't worry. This whole thing is being recorded, so you can always replay it. And the notebook has a little bit of information by itself, so you guys can always follow along. Maybe I'm modifying here and there with a couple of things to generate more data, or just not more data, more analysis or methods. But the core of it is already generated. All right, so let's group by legendary. Barney Stinson. So all those Pokemons that are legendary, and I'm gonna do that. So per group, right? We're gonna get the count of how many legendary Pokemons we have. So it seems like Generation 1 had only 4 legendary Pokemons, 5, and then it went up, and then it went down again, right? So this is the sort of analysis that you folks can make. What about multiple groups? Let's group first by generation, and then let's group by type 1. So per generation, then we're grouping by type 1. Let me show you right there what it looks like. So for generation 1, we have the types bug, dragon, electric, fairy, fighting, fire, etc. These groups, as you can see, this structure right here has like 2 important divisions. First, the generation, and then you have the type for each one of them. The aggregation is the average attack, the mean of attack. So what we're going to do right here is turn this thing into a nice data frame right there. So we have generation 1 type bug, generation 2 type bug, etc. And again, the value is the mean, the average value of attack. And now we can build this pretty dynamic plot. There you go. That is showing the evolution of the average attack for each generation, in each different type 1 category. This looks crazy to look at, right? It looks like a huge, I don't know, salad of lines. What we can do is use instead another charting library, which is Boki. This Boki library, it's a really neat library. What it's going to let you do is dynamic JavaScript powered charts. And let me show you what it looks like. Right there is this dynamic charting library. Why is it dynamic? Well, I can turn on and off the different lines. So let's leave, for example, fire, water, psychic, rock, and grass Pokemons, and see the evolution of each one of them through time or through different generations. So I'm picking up the questions here. Baka Brooks, what's the difference between lock and iLock? Lock is gonna let you select by index. Let me jump ahead to the third notebook. Everybody aware, I'm in a different notebook, more visualizations. And in this case, we're picking up. I'm gonna go ahead and yep, there we go. Is let me do something different here. I'm gonna do open and close. I'll show you folks what the difference between lock and iLock. There we go. So this is our Amazon stock price. Lock lets you select by index. This is the index of my data frame. You guys are in Excel, you're used to have an index, which is the row, an index, quote unquote index. With Pandas data frames, you have a real index that, again, identifies that value you have. In this case, the index is the date of that price. So for November the 13th, we have that the open price, the open, high, low, and close prices. And also we have information about the volume transacted. So this is the index. If I want to select this value, what I'm going to do is df.lock. I'm going to pass that value. And this is, again, the same thing that I had before. Now, if I want to select, let's say that I don't know about the index and I want to select the, I don't know, 10th value. 1, 2, 3, 4, 5, 6, 7, 8, 10 by sequential order, top to bottom. I want to select the value sequentially. In this case, we want to select the first value, for example. For that, we're going to use here df.iLock 0. Python is 0 indexed, so the first element is 0. There you go. So in that case, the selection is done sequentially. We're getting the first element. Or what about the last element? Let's pick really quickly the last element. I'm going to do tail here to get the final 5 elements in my data frame. So it seems like November the 17th, 2014 was the first, actually the last value in my data frame. To get this one directly, I'm going to use lock by this index. If I want to get it by sequential position, what can I do? Well, I could do, for example, df.shape, and I can get how many values we have. We have 251 values, so here I could do 250. That's it. That's the final value. You're going to see open 326.44, 326.44. Or as this thing is Python, you can also use negative indices. I can get the value in position -1. So the first one is 0. The last one is -1. iLock is sequential. Lock is by index. You're welcome back. So James, when does the notebooks invite come through? The notebooks invite is posted above. So if you just scroll up, you're gonna see it. All right, so as we are on this thing, I want you guys to keep an eye on it. It's just for you to see time series. We know that some of you are working, for example, with time index data. You're maybe accountants or just working on marketing, sales, and you're dealing with time series, with numbers indexed by time. Time series management is extremely simple with Pandas. It's very powerful. Here's a quick example of plotting Bollinger Bands. If you guys want to check it out, just what you guys can get with a couple of lines of code. It's like 4 lines of code, literally. So simple. But finally, to wrap it up, I want to leave you a couple of exercises for you folks to practice on top of the same data frame we have pulled, which is right here, the Pokemon one, right? So the Pokemon one with all our Pokemon generations, legendary status, etc. This one right here, you can just run these lines and you can start coding it. So for example, find the strongest Pokemon. Strongest defined as max attack. So df at attack gonna give you the attack of all the Pokemons. You could run summary statistics on it. So you could do, for example, max here, right? If you folks want to reveal the solutions, I was actually gonna point to this. So if you are stuck, you can always reveal the solutions for each one of these. Some of these will have hints that it's perfectly fine if you folks wanna check them out, all right? And the idea is for you to have a little bit of practice of what we have done so far in this class. Patricia, are you that is strange. If you're following the notebook, that shouldn't be the case. One important thing for everybody getting started with this, if you screw up with your data, as long as you haven't written it back to the disk, you can always recreate it. So for example, I can just run this line again and again, and the data is read once again. So let's say that I set Bulbasaur, I'm gonna do 1, I'm gonna do at HP, I'm gonna do equal 0. So now, for Bulbasaur has HP equals 0. I have just screwed over my data. I can always reread it. Reading this line again brings everything back to normal. So that's why your notebooks, this is just completely unrelated to, I mean, it's related, but it's not technically speaking data analysis with Python. But it's best if you can keep your notebooks organized and sequential. Like keep an idea of all the steps you have followed in your process. Because if something goes wrong, if your computer crashes, you can always go back again to the top and start running things one over the other. That's the best way of doing it and working with it. Yes, there is a way to rerun the current line in the notebook. So yes, 2 things. First, you can restart the whole notebook. So this could be a good thing for you to do. You can go to kernel, restart kernel, and clear all outputs. It's gonna get you back to square one. I use this a lot. And again, if you have your data organized, your steps organized, you can always replay them one by one. Let's say that you have restart everything. What you can do is now you can go to one of these lines, for example, right here, and you can do run all above selected cells. So it's going to run everything for you. You will see a little star there until this one right here. So you have just run everything. And again, if you want to rerun just one specific cell, you can always do it. Just go to your cell and you can, for example, here, run cell, or just shift enter, control enter, and it just works. So that was our very quick introduction to data analysis with Python, especially all the tools you guys will see and hopefully you can start picking up from these examples. We have shown you a little bit of each one of the topics that we usually follow. We are showing you how to read data. We're showing you how to generate new data, how to clean it, how to group it, how to visualize it. We saw line charts. We saw column charts or bar charts. We saw a pie chart, box plots. We saw pretty much everything. So hopefully you can just keep this introduction for you later. If you have questions, we have a Slack community that we have posted around. And also, if you are interested about our course, check it out. Again, it's pretty much what we've seen today, spanned into 3 months because we have a lot of programming within it. So it's something for you to check if you are interested. So rerun is great. There you go. So it seems like everything is working now. I'm glad to hear that. If you guys have any questions, again, get in touch with us. And I hope you can these tools useful. All right, we use them all the time, and we know that the community is revolving around them. So have a great night, everybody. Kitty, were you checking the correct file? Should be able check if you didn't accidentally change the name. It should be datasets pokemon.csv. And if you folks check, there is a file structure here, file directory structure, which has datasets within it. And here you have the 2 datasets we have worked with, pokemon.csv and ANS. All right, you can, in Jupyter Lab, you have this nice CSV view you guys can use. And also you can open it with an editor in case you need that. So Skitty, check that, the name, all right? Again, check if the file is there first, all right? If you go to datasets, if the file is there, and if the name is correct. All right, everybody, have a great night. I hope this was informative. And yes, Slack link. I'm gonna share it right away. Share it if you guys give me a second. You're welcome. I can't find the link. So I'm gonna post it as a comment as soon as I'm done with the video. So I can pause the recording, it can get uploaded, James, and that is it. James, if you wanna, if you don't see it there, just email me and I can send it to you in a couple of minutes. All right, folks, have a great night. And again, try using this, it's very interesting and fun. If you have questions, let us know. Have a great night.